Okay, so this is the sine law and ambiguous case worksheet. In this first question, they're just asking you to calculate the ratios for the following angles to three decimal places. I've gone ahead and done it for you with the calculator. Now, what pattern do you see? Well, it looks like sine of 50 and sine of 130. Those two angles produce the same ratio. Similar thing for cosine and tan, except there's a reversal in sine. So they are asking a question below. They say, let me just zoom out a little here. They say, so if a question asks to solve for theta, given that sine of theta equals 0.774, how can you tell if the answer is supposed to be 50.7 degrees or 129.3 degrees, unless you are given more specific information? Both answers are correct. Isn't that right? You could have two possible answers for this one. Two possible answers that could be correct. So let's look at the key idea down here. It says the ambiguous case is a scenario in which there are two possible and equally valid triangles that can be made with the given information. This can happen, but doesn't always happen when you are provided with two sides and a opposite angle. So let's take a look at this, for example. I can draw just this triangle right here that has a side length of 4 centimeters. This could be 5 centimeters, and this could be my 30 degrees. So there's A, there's B, this could be C, and this is side B, and this is side A. That's one triangle, right? What about a triangle that looks something like this? Could this also be valid? Could this also be 30 degrees? Could this also be 4 centimeters for A? And could this also be 5 centimeters for B? Could this work as well with the given information? It looks like it does, but it produces two different angles for B. Like that could be theta 1, that could be theta 2. And there's a different angle up here. We can call this gamma 1, and we can call this gamma 2. So two different angles there. It turns out that I've kind of been deceiving you, not intentionally, but just in the efforts of introducing things slowly or giving you a little bit of information and then allowing you to feel comfortable with it before going on to more information. But look at something like this, where we have an angle and there are two sides that are provided. Well, here's an example where we would have to consider the ambiguous case, where we didn't. With this information, we could probably draw two triangles that meet the criteria. So another triangle might be, for example, this, where this is equal to 10.2, and we get this small skinny triangle here. That could also work, right? So again, the ambiguous case is when you can draw two different triangles for the given information. We're going to be solving problems with the ambiguous case. But before we do, I just want to make a connection to the next unit that we're going to be chatting about, and maybe it'll provide you with some information to assist you in figuring out how many cases you have. So if sine is expressed as a function, it has the following general equation. F of theta equals sine of theta. The function of sine receives input of theta and produces trigonometric ratios of sine for the given angle. Recall, a trigonometric ratio is a ratio of the side lengths of a right angle triangle. So that's all it is. If we take all of those ratios and plot them on a graph, we get something like this. And this is the graph of sine. So this is f of theta equals sine theta. And it goes on forever in both directions. But here it is between 0 and 360. Now, take for example, what was this example that we were looking at before? I think it was 54 degrees, if I'm not mistaken. Let's see. Well, we're going to come back to it in 1 second. But essentially, imagine like with this example here, if they're asking us to draw out this information, let's kind of get going and then we'll come back to that graph of sine shortly. It says in triangle PQR, where R is 40.3 degrees, side length is 35.2, and Q equals 40.5, what's the situation that we have going on here? So I would kind of draw this out like this. And let's assume we have one triangle for now, and I'll show you how to figure out if you have more than one triangle, just in 1 second. So that's PQR there. Angle R is 40.3 degrees. Side length R is 35.2 centimeters. And side length Q is 40.5 centimeters. And they want us to, I guess, solve the whole triangle. So let's figure out what angle Q is using the sine law. So let's say sine of 40.3 divided by 35.2 equals sine of Q over 40.5. Let's bring the 40.5 over. So sine of 40.3 over 35.2 times 40.5 equals sine of Q. Let's punch all this in a calculator. So sine of 40.3 divided by 35.2 times 40.5 is 0.744. So this is the point at which you want to look at your graph of sine. Our trigonometric ratio is 0.744. So if this is 0 and this is 1, it looks like 0.744 is somewhere over here, right? You want to go across and you want to think about it. How many potential angles are you going to have? And it looks like there's two potential angles. We can call them theta 1 and theta 2. That when you evaluate them for sine, produce a ratio of 0.744. One of them is in quadrant 1, which makes sense when you think about your cast rule. One of them should be between 0 and 90 degrees. And it also makes sense that the other one is going to be between 90 and 180 because it's a positive ratio, right? And we have positive ratios in the second quadrant. So to find theta 1 or theta 2, whichever one it is, you just take the inverse of this. So let's do sine inverse of that. And it should be 48 degrees equals angle Q. We'll call it Q1. Now to find Q2, just remember, like if this is 48 degrees, all we have to do is look over here and make this our reference angle of 48 degrees. And then this will just be theta 2 or Q2 for us. So that's the same thing as taking 180 degrees and subtracting 48 degrees. So 180 minus 48 is going to give us Q2. So Q2 should be 131.91 degrees, approximately. So it looks like this is one triangle where Q1 is equal to 48 degrees. But just as equally, we could draw another triangle here with the same basic information that we started with. But the only difference is that now this angle of Q is going to be 131.91 degrees. And that's going to change this angle for P and the side length for P. And you could go ahead and figure those out after. Let me just make a note here that we have two possible answers. Let's look back at the graph of sine just for a second. If your value of sine is equal to 90, that means you're only going to have one solution. And if it's equal to 0 or 180, that looks like you're going to have, well, an angle of 0 isn't really possible, and an angle of 180 is just a straight line, so I don't think those would produce triangles. But anywhere kind of in that range from, 0 to 1 is going to give you two potential solutions. So that's just something you want to make a note of when you're thinking about your ratios of sine. So, might be a little bit unclear there. So let me see if I can just fix the focus. How to tell if you're dealing with the ambiguous case? Well, you should be given the following arrangement. So a side, another side, and an angle. And one angle, we can call it theta 1, can be calculated via sine law. And the second angle, theta 2, will be equal to 180 minus theta 1, just like we kind of did in that previous question. 4 cases. So no triangles, remember, if it's equal to 0 or 180. One triangle if it's equal to 90 degrees, and 2 possible triangles if that ratio is between 0 and 1. Don't worry about this case number 4 here for now. Okay, let's give this first one a go. Determine the number of possible triangles for the given triangles. Isn't that funny? What a strange way to word this stuff. Okay, so triangle ABC, where A is 42, or angle A is 42, A is 30 centimeters, and B is 25. So why don't I just draw potentially what we have here? So this is A, we can call this B, that's C. Angle A is 42 degrees. Side A is 30 centimeters. Side B is 25 centimeters. And why don't we go ahead and find angle B? So let's use the sine law. We'll say sine of B over 25 equals sine of 42 over 30. Let's take that 25 over. So we'll have 25 times sine of 42 over 30, which is equal to approximately 25 times sine 42 divided by 30, 0.557. So let's go back and look at our graph of sine again. It probably would be helpful to memorize this graph if I'm being honest with you. And here's your major points. So 0, 0, 91, 180, 0, 270, negative 1, 360, 0, because this is going to come back again in our next unit. It's so foundational to everything we do this year and next year. So here's 0. What is it? 557. And we can see that we have two potential angles, right? One of them is between 0 and 90, and it's probably less than that angle we figured out there, which was 48 degrees for the previous question. And it looks like this one here is probably closer to 180. But nevertheless, we're going to have two solutions here. So to figure out that first solution, we just take the inverse. So b equals sine inverse 0.557, which should just be 33.89 degrees, which would be this case here. It's an acute angle. And remember, acute just means an angle between 0 and 90. And it looks like we're going to have another case. So we can call this B1. And it looks like B2 should just be 180 minus B1. Or 146.11 degrees, approximately. So two potential triangles. So therefore, two potential triangles. And that's all that they wanted us to figure out for this question. How many potential triangles can we have? Obviously, from here, you can draw out your other triangle, which will look something like this. And there would be your angle of 146.11. And everything else stays the same. So there's our two triangles. Okay, if you want to take a minute to pause the video here, you can try example B on your own. When you're ready, just go ahead and click play. We'll run through it together, and you can see how you've done on this one. Okay, I think I'll get going on this now. So let me just draw that first potential triangle again. We've been starting with the acute angle, right? And I think we've had good luck with it. So I would say start with the acute angle always, and you might have good luck. Okay, there's what we're starting with. Same thing as before. Let's start with the sine law. So sine of angle C over side C equals sine of angle B, which is 27 over 25. Let's take that 30 over to the other side. Let's evaluate all this. So 30 times sine 27 over 25, 0.554, which is really similar to what we got before. So this is also going to be two triangles. We don't even need to go any further because we know we're going to get two angles, right? If I take the inverse of this, it should be 33.01. We'll call that C1. And C2 should just be 180 minus this value. Or 146.98 degrees. So therefore, two potential triangles. Okay, let's flip over. It says now solve the following triangle. So I think what you're going to have to do for this is determine how many triangles you have and then solve them both fully, which means finding all of your angles, all of your side lengths. There's this application problem here. It says a triangular garden is enclosed by a fence. A dog is on a 5-meter leash tethered to a fence at point P. One corner B of the fence is 6.5 meters from P and forms an angle of 41 degrees as shown. In the diagram, determine the total length of fence that the dog can reach to the nearest tenth of a meter if the dog cannot reach side AC. Well, interesting. I gotta double read this, or I gotta read this through again. I don't know. I gotta read through that. That's an interesting one. Think about that one. See what you come up with. There's some questions here that you can do for homework. And that's a wrap on this lesson. So what I'm going to say is for these questions that I've just skipped over here, you can check Brightspace if you want to look at the answers. I'm going to pause it here because there is nothing new to teach you guys. This is essentially the lesson. So hopefully you found this useful. And yeah, wish you the best of luck. Make sure you're being productive and making your way through these problems. If you got to go back and revisit some parts of this video, please do that. And feel free to pause, rewind, all that sort of stuff. Okay, I'll see you in the next one.